Hello and welcome to Technical with Kranti, and today we are going to solve another question on recursion, which is rat in a maze. But before that, let's have a look at the thought for the day. Alright, so these are the videos that we have done in recursion, and let's have a look at the question. You are given a matrix of size n cross n that represents a maze. So from maze, we know that maze has a lot of paths from the initial point to the final point. Some paths lead to a blockage, and some paths lead to destination. So we need to find all the paths that lead to the destination. In this particular question, we have a mouse or a rat sitting at 0 0 position, maze of 0 0, and it has to go to maze of n minus 1 comma n minus 1. And we need to tell all the paths that the rat can take. Now, in this maze, there are cells, and all of them are filled either with 1 or with 0. 1 is where the rat can go, and 0 is where the rat cannot go. The rat can move up, down, left, right, but the rat cannot revisit already visited cell in a particular path. So let's have a look on the whiteboard. All right. So I have made a maze over here. This is our rat. All right. As you can see, from the starting to the final position, there is this one path and another path is this. Okay. What we'll further do is we'll create a matrix of the same size as this maze matrix. We'll call it visited matrix. This visited matrix will serve two purposes. One purpose is it will tell whether or not a particular cell is already visited or okay. So as we keep visiting some cells here, we'll mark those similar cells one over here. As the rat can move in all the directions, it can it may also step upon already visited cell which we need to avoid. So we'll have a check over here that if the same cell in the visited matrix is 0, then only the rat can visit it. Right? So this is one purpose. Second purpose is when the rat reaches its final destination, then once marked over here would serve as the path. So we'll get to know what is the path using this matrix. All right. How are we going to now solve it? We basically would use recursion and backtracking because there are more than one valid paths. All right. Now let's look how can we find the first path. Okay. We need to see that in what all directions rat can move. Rat can move in this direction, up, left, and down. All right. So from any particular position, it can go into four directions. And in all four directions, there is one cell where it can go. Okay. So for a particular cell, whether or not rat can visit it, we need to define the conditions. What are the conditions? The first condition is that maze of row comma column should be equal to 1. Second condition is visited of row comma column should be equal to 0. Okay, these are the main conditions. There is one more condition which is kind of a robustness check, that row should be greater than or equal to 0 and it should be less than n, and similarly for the column. All right, so these are the conditions. So that is it. On any particular cell, it will just check for all the four directions these conditions, and then recursively move along those directions. What would be the base condition? Base condition would be if R and C both are equal to n minus 1, then we have reached the destination. And whatever is the path indicated by the visited matrix, add that to the answer and then find other paths. All right. So this is the basic algorithm. Let's have a look at the code. So we have this maze matrix with us to begin with. I have formed an answer list and a visitor list, the two matrices which I had shown on the white. Then to begin with, 0, comma 0 of maze should be equal to 1. All right. And then I'll call this function which will do the recursion. So what are these entries? This is the row, this is the column, this is the maze, this is the length of the maze. So it's an n cross n matrix. So that n value this is. This is the answer matrix. This is the visitor matrix. This is just an additional argument which is representing path. Okay. This is optional. All right. So now have a look at the solve function. Right. I and j are the row and column values. And if these are equal to n minus 1, n minus 1, we are appending the answer. This is the base condition. So we can move down by incrementing the value of row. We can move left by decrementing the value of column. We can move right by incrementing the value of column. And we can move up by decrementing the value of row. So from 0, comma 0, as we can see, we can move right, which means that this will fail because maze of this value is equal to 0. This is fail because j minus 1 will be out of bound, and this was going to be the valid condition. So what we are going to do here, we are going, we are trying to go to maze of 1 comma 0 from maze of 0 comma 0. So we are marking 0 0 as visited, and then we are going to solve for I equal to 0 and basically column equal to 1, right? So when again this recursive call happens for the changed value of I comma j, we'll see down, left, right, and up. So for example, if we come over here for left, all right? So from here, rat can move left, but this is already visited matrix. So that is why we had said visited of I comma j equal to 1 when we were moving right here, right? So that after moving right, it cannot go left. All right. So with this recursive call, again, we'll go on to check where it can move down, left, right, up. And correspondingly, once the valid path ahead is known, then the given cell is marked with 1 in the visited matrix. All right. When I and j is equal to n minus 1, n minus 1, we'll use the visited matrix to find the path. So we'll create an empty list, and then each element row wise is inserted into this and is appended into the answer. While returning back, we will come and mark this matrix cell to 0 again, because that path is now already included in the answer. So we are going to find other paths. And when other path is to be found, then the visited entries of the earlier path should be set to zeros, right? Because now we are finding the different path. So that is why after recursion call, we are setting the same I comma j in the visited matrix to 0 again. All right. All right. So the answer is same. It is just that they are printing it as a string and I have printed as a list. And over here, the order of answer is different. So answer is the same only. Four paths and but their order is different. That is it. All right. So I hope that you understand the question, the approach, and the solution, the code of it. If you did, please give it a thumbs up and subscribe to my channel. Thank you. Bye bye.